Welcome to the DIY Honda Garage channel. The DTC P0237 indicates a low voltage condition in the turbocharger boost sensor circuit. This diagnostic trouble code affects the signal communication between the turbocharger boost sensor and the powertrain control module, PCM. The turbocharger boost sensor is responsible for measuring the pressure of the air coming from the turbocharger, which is critical for optimal engine performance. Located on the intake manifold, this sensor interfaces directly with the PCM to help manage fuel delivery and ignition timing. A low voltage signal generally suggests either a fault in the sensor itself or issues in the wiring that connects it to the PCM. Understanding the functionality and location of these components is crucial for effective troubleshooting in resolving this DTC. The DTC P0237 is defined as a turbocharger boost sensor circuit low voltage error, which affects the ability of the turbocharger to deliver the required boost pressure. This low voltage can lead to suboptimal engine performance and efficiency, potentially triggering a check engine light. Located on the intake manifold, the turbocharger boost sensor plays a critical role in monitoring the boost pressure generated by the turbocharger. If this signal is too low, the PCM may not be able to adjust the air-fuel mixture correctly, therefore impacting engine performance. Understanding these aspects helps in diagnosing the issue accurately, as the sensor and related circuits must be verified for proper function to restore optimal vehicle performance. Potential causes of the DTC P0237 include a damaged turbocharger boost sensor, which may fail to send proper voltage signals to the PCM. Poor connections or loose terminals at the turbocharger boost sensor or PCM can also contribute to low voltage issues, as they disrupt the integrity of the electrical circuit. Additionally, open or shorted wires within the circuit may lead to incorrect voltage readings, causing the system to trigger this DTC. Identifying these potential causes during troubleshooting is essential for systematically eliminating possible sources of the error, thereby effectively diagnosing and resolving the issue. Symptoms associated with the DTC P0237 may include reduced engine performance, characterized by sluggish acceleration or lack of power. This occurs since the turbocharger may not operate effectively without the correct boost pressure. Additionally, the check engine light will likely illuminate on the dashboard, indicating that a fault has been recognized within the vehicle's systems. Drivers may also experience turbo lag, where the vehicle may hesitate or take longer to respond when acceleration is requested. Recognizing these symptoms will aid in pinpointing the issue and addressing it promptly to restore the vehicle's performance. The first troubleshooting step for DTC P0237 involves verifying the problem when the vehicle is in the on mode. You should check the TC boost pressure sensor using the Honda Diagnostic System, HDS. Specifically, you must ensure that the sensor's reading is at a threshold of 0.23 volts or less. If the sensor's current conditions meet or exceed this threshold, it confirms an existing issue that necessitates further investigation. However, if the results indicate that the system is okay at this time and meets the threshold, it suggests intermittent failure, possibly caused by poor connections or loose terminals needing inspection before proceeding with deeper diagnostics. For the second troubleshooting step, turn the vehicle to the off, lock mode, and disconnect the turbocharger boost sensor at the 3P connector. After this disconnection, switch the vehicle back to on mode, and again use the HDS to check the TC boost pressure sensor readings. Here, once more, the sensor should reflect a value of 0.23 volts or lower. If the readings are consistent with this threshold, proceed to Step 5 for further verification. However, if the condition does not match the expectation, you'll need to move on to step 3 to focus on potential failures within the sensor itself. In the third troubleshooting step, you'll measure the voltage between specific test points using the turbocharger boost sensor's 3P connector while it remains disconnected. Position your measurement probes at test point 1 on the female terminals number 1 and at test point 2 on female terminals number 3. With the vehicle in on mode, you should be checking for a reading of approximately 5.0 volts. If you confirm this voltage is present, it indicates that the sensor has malfunctioned, requiring you to replace it. If the voltage is not present, proceed to step 4 to investigate further towards possible wiring issues affecting the circuit. Now in step 4, the goal is to check for continuity in the VCC2 wire. You'll want to first turn the vehicle off, lock mode, then jump the SCS line using the HDS and wait for over a minute. Disconnect the PCM connector E, 80P, before checking continuity between the test points as outlined. You'll assess the signal from the turbocharger boost sensor 3P connector number 3 against PCM connector E, 80P, pin 77. Observing continuity means that the VCC2 wire is intact and functioning properly. Thus, possible faults may lie elsewhere in the system. However, if there is no continuity, you will need to repair any identified open circuitry in the VCC2 wire between the PCM and the sensor to resolve the issue. The final diagnostic step involves checking for a short within the P3 line. Begin by ensuring that the vehicle is in off lock mode. Then jump the SCS line once again. Disconnect the PCM connector E, 80P, and assess the continuity between the turbocharger boost sensor, female terminals number 2, and body ground. If continuity exists, this indicates a short in the P3 wire, which needs immediate rectification. On the other hand, if there is no continuity, it suggests that the P3 wire is functioning correctly. At this point, it may be prudent to seek additional service information specific to the DTCs or symptoms you are troubleshooting, or consider substituting a known good PCM to further isolate the problem. After completing the repairs related to DTC P0237, it's essential to conduct a final verification to ensure the issue has been resolved. Start by running the vehicle through a series of diagnostic tests to confirm that the turbocharger boost sensor is providing accurate readings and that communication with the PCM is restored. It is also beneficial to look for any lingering codes and monitor the performance during a test drive under various conditions to ensure the turbocharger's functionality is intact. If all systems indicate normal operation and no reoccurrence of the DTC is detected, the repair is validated as effective. Properly documenting the completion of these steps will also assist in any further diagnostics that may arise in the future. Conducting preventive maintenance can significantly mitigate potential failures associated with DTC P0237. Regularly inspecting and maintaining electrical connections related to the turbocharger boost sensor is essential to ensure they remain free of corrosion and securely connected. Neglecting these connections can lead to fluctuations in voltage readings, triggering DTCs and ultimately causing performance issues. Additionally, routinely inspecting turbocharger components for wear or damage will contribute to better overall engine efficiency. By proactively addressing these areas, the chances of encountering low voltage conditions or performance dips due to sensor malfunctions can be substantially reduced, fostering a healthier vehicle lifespan. In conclusion, DTC P0237 highlights the importance of the turbocharger boost sensor in maintaining vehicle performance. Systematically following the outlined troubleshooting steps allows for efficiently identifying and rectifying issues linked to low-voltage signals. By meticulously verifying each component and connection, you can pinpoint the root cause of the DTC, whether it's a faulty sensor or wiring issues. This structured approach not only addresses the immediate concern, but also fosters a deeper understanding of the turbocharging system's role in engine efficiency. Additionally, by implementing preventive maintenance practices, such as regular inspections, you can minimize future occurrences of similar DTCs, ensuring a smooth driving experience. Please like and subscribe to the channel. See you next time.